Hello. We are tackling this particular integration problem today, and looking at this is rather, disgusting because it's got a sine x on the denominator, and then got the cos x squared. Now, I hope everybody understands that this expression can be interpreted as cos x or square. All right, so they're the same thing. So, indeed, it is when you first look at it, it can be quite overwhelming. But this is actually a very simple question, a simple integration problem to solve. But we have to use the right method, right? Now, of course, this is not a easy integration problem that you can just look at it and know the answer. This is not like integrating x by dx. It gives you, x squared over 2 plus c. Not that simple, right? So, but it requires a method called integration by substitution, right? Integration or integrate by substitution. Now, substitution resemble a lot. Substitution. So let me rub this off. Substitution. Now, substitution, this particular process resemble a lot like chain rule. All right. So, what in the question tells me that I need to use integration by substitution? Now, this is very easy to identify. If you see, a fraction or anything, if you see that the derivative of something, or in this case either sine or cosine, is already there, right? Remember, the derivative of something, or one of the component of the fraction, it is already present inside there in the fraction, then you can use integrate by substitution. Right? Now, in this case, I know the derivative of sine is cosine. Right? And I know the derivative of cosine is also sine. Alright? So we can, this is the clue that the question is telling us that we have to use integrate by substitution. Now, in this case, I will break this into two parts, alright? Because I know the integral has a distributive characteristic, so it can be treated as this. Alright, so we do it part by part. Do this and then minus this. Alright, we'll break it down, work it step by step. You might find out later why I do this, because it can get messy if you do it all in one go, if you don't name your variable correctly, if you don't have a good order at naming them. So let's talk about this part first. Now, I know that the cos, I say right now, okay, let's say, just a chain rule. We say let u equal to cos x. Alright, so we placing cosine x with a variable, called u. Now, I know differentiating u with respect to x, du dx, in this case is negative sine x. Right? We are just differentiating cosine x with respect to x. Right, now the next step is quite interesting. Now, not many people, well, when I first learned this particular method from my teacher, I was like, you can do that. But obviously there is a mathematical concept behind it that allows you to do something like this. So this here can be treated as a quotient, right? Something divided by something. So if you can do that, then I can move the dx to the other side, right? So that become negative sine x dx. Which makes sense, because if you cover up this side, you just look at negative sine x dx. It's just meaning doing this, right? Negative, and that give you cos x, right? That makes sense. So let's take that off first. So the next step is move this negative sine x to the other side, right? It becomes this, right? Because it's a multiple sign here. So that gives us dx. Now we have an expression for dx, right? And let's sub this expression back in here. That will give us, that will give us integrate sine x over, now normally down here is the cos x all square, right? But remember, we already make cosine x equal to u, right? Just a bit up there, right? So cos x is already equal to u. So cos x all square is literally just u square, right? Yeah, following the logic there. So we can just write u square here. And the dx can be just replaced down here. So we can just replace it by multiplying du. Now, why is it multiply? Because this is multiply. Right? A lot of people don't pay attention to this little detail here. This does mean multiply. Okay? So the dx matters. Right? People don't just write it there and think it doesn't do anything. Right? It matters when it comes to this particular situation. So and then we just put a negative sine x over here. Now the whole purpose of this is to cancel out the sine x now, right? You can see that you can do it like that, right? Because they're multiplied, and you can cancel like that. And that will leave us with negative, remember the negative is still here, 1 over u squared, right? du. Right. Now, this is much easier to do, right? We know how to do this. We have changed the scenario back into something that we are very familiar with. This is just a polynomial, right? Which is polynomial with, you know, at the denominator, at the denominator, denumerator. English is not my first language. All right. So we can treat this as negative u to the negative 2, right? Because we're just moving it back up to the numerator, right? And now the step is easy, right? It's just the reverse of a derivative, right? So we have to add 1 to the power, so now it becomes negative 1, right? Divided by the new power. Right, and that's it. Remember the plus c. Well, in this case, the plus c's can be written later because we also got the other part of the integral to do, right? And then the c can just be gathered into one constant. So we can run it now. We can run it. That doesn't matter. So that's it, and that will give us negative. Oh, no more negative, remember? It's negative divided by negative is it's positive now. So it will be just u to the negative 1. Alright, in this case, I will just write it as 1 over u. Alright, much better to keep the index, the exponent as positive. It's a good convention to do that. It's a good, good habit to do that. And then plus c. Now, don't forget, our u is actually cosine x. Right? Our u is actually cosine x. So this means that we get 1 over cos x plus c. Right? Following me so far? Now, the other side of the integral, the other side is pretty much the same. Right? So we let's say we use v now, we use u now, let's use the v, right? They're very this two letter comes out a lot in calculus for some reason. So we let v, in this case, same thing, we choose the bottom one, right? We choose the bottom one with the more powers in there. So we choose, let that become sine x. Right, let v become sine x or equal to sine x. So same process, we differentiate v with respect to x, would give us cosine x. Right, and then we bring the dx to the other side by multiplying it. And then we move the cosine to the other side by dividing it, which gives us an expression for dx. And then we make this expression, we replace our integral with this expression that we come out with. So we are integrating cos x over no longer sine squared, no longer sine x squared. Now we have v squared. Right? V squared, because v is equal to sine. And then dx becomes whatever we got up there, which is du over cosine x. Right? Now the cosine x cancels. Cool. Leaving us with 1 over v squared. Oh, not du. I'm making such a silly mistake. Not du, it's dv. Where's the u coming from? No u there. It's dv. Scared me out here because I was like, I got a v here and there's du, and I was like, wait a minute. Okay, this is dv. Good. Now we can just integrate this, right? It's simple, easy. Just a polynomial. All right, let's move this down a bit. Oh my god, where my mouse gone here? Okay, so this is same as integrating v to the power of -2 dv, right? Which give us that across, which give us add 1 to the power, right? Becomes -1 divided by the new power and plus c, right? So this would give us -1 over v plus c. And since v is just sine x, this is -1 over sine x plus c. Right? So let's combine them together, right? Because this is one question, and since we just separate them to do it separately, so therefore it's good to write the whole question again. All right, sine x all over cosine x minus cos x over sine x squared is equal to, we just write each part down, right? So it's equal to 1 over cos x minus, the reason it was minus because we got a -1 over sine x over there, right? So it's minus 1 over sine x plus c, right? That's it. That's how you do it. So that's the answer. So this particular method we just used is called integration by substitution. Now I know I'm not the best person who explains this particular method, and for those of you who watch this particular video, and if you want to learn more integration method, which I strongly recommend you do, because learning what your high school teacher, what your year 12 teacher, what your year 11 teacher to teach you it's not enough. I don't find enough fun in there, right? I want to learn more. I want to use different methods, so whenever I come across a question, I can integrate it without a problem. So for those of you who want to learn more about different integration technique, I strongly recommend my teacher's videos to you. My teacher, his name is Dr. He's not. I don't know if he's a doctor or what, but we call it. And he's in US. He's in the US. He's called Professor I spelled, is it one F or I will just do one F, okay? Professor, yeah, Professor, Leonard, Professor Leonard, right? Go to his YouTube channel. He got a YouTube channel. So just go in YouTube and type his name down there. And then he has different playlists. And I would focus, if I were you, I would focus on his Calculus 1 and Calculus 2 playlists. Personally, I learned a lot from him, right? And just like most of you, I'm in Queensland, Australia, Queensland, and Brisbane specifically. And my math high school teacher taught me a lot, but I wouldn't say I have great respect for my teachers, but I reckon Professor Leonard went into a bit more depth and with a bit more effort he put in. His video is not boring. It's fun to watch, or at least for me. And so I recommend you guys to have a look at it. And if you trust me, if you look at all his Calc 1, Calc 2, and if you're planning to pursue mathematics in university, check his Calc 3 out. You have to check his Calc 3 out. Trust me, I guarantee you, if you learn everything from him, you will pass the exam with a 7. Definitely. Okay? Well, 7 as in university GPA. And you definitely get an A, let's say that, in an exam, in your high school exam. So make sure you check it out.